y'all. This is Darryl Berry Jr. back with a different type of shorter day, just this a bit. So I've been looking for somebody to get on, either to debate or to discuss. And I spoke with someone named Kyle Lee on one of the new Discord channels who is an ex-flat earther. So I figured we'll get him on and spend maybe the next hour and see what got him into flat earth and what got him out. So it seems like it'll be an interesting thing. So he is joined here. Let me bring him on stage if I can. Uh, there we go. What's going on, Real Kindness? It's awesome. Holly is on the stage. What's going on, man? Thanks for joining. Welcome. And I got the stream all started. Let me get the stage showing. Now we have one person watching so far at least. And we'll get this started. And maybe somebody may want to join the boom, there we go. The stream is showing. And the link is in the uh scrolling up on top as well as on the right side. So be sure to join if you want to join. You could join the Discord and get into the audience. Um and maybe we can have more on on the stage later. But also we can go ahead and get started. How's your day been, Kali? Awesome. Whereabouts are you at anyway? Ah, that's right. So I'm in Texas. It's hella hot here. I actually had an exam today, so I'm glad to be done with that. So I'm gonna start getting ready for the next semester. So actually, it was an exam to get into grad school, the GRE. So I went and took that today. Wasn't all that bad. I think I did well enough to get into grad school, but cool. Thanks, appreciate it. It's awesome. Why don't we start with the beginning? How did you get into? Oh, and hold up. They're saying no audio on college. Let me see what's going on here. Thanks, kindness. So maybe I mess. Oh, that's what it is. My bad. I didn't change my default.
Hello, hello, Mick.
Oh no, you're good. You're good. I have a dorm mate now. I was so used to streaming without having a dorm mate, so I have my headset on. And usually I have my audio set for like the actual computer audio, so I didn't actually change it to my headset. Is what it was. To try one more time, if you'll say something.
Mic check. Hello.
There we go. You're good. So thanks for your kindness. Let me know if I need to adjust anything. And he was just saying he's from California, and we'll go ahead and get started. So, how was it that you got into the flat Earth thing? Like, what got you into it?
Yeah. What got me into it? Bro Sanchez TV. I was watching him, unaware of what flat Earth really meant,
Okay.
and then there was there was a documentary, Lost History of the Flat Earth, by AWAR, and in it, he pretty much like changes the opacity of the A.E. Gleason's map and like fixates it over the moon. And it's like,
Okay.
look, the land masses on the Earth kind of match the spots on the moon. And it was really compelling. He made it look like it all made sense. So that was really compelling seeing that moon map thing at first.
And maybe I'm missing that. So they overlaid you see, a map of the Earth onto the moon.
That's right. Yeah, you could find that on the YouTube channel, Vibes of the Cosmos.
Okay.
And yeah, uh, really, really straightforward. The land masses of the Earth kind of line up with the splotches of the moon a little bit.
See, see if
You
I can
squint at it.
find that. I'll try to pull that up. What was that channel? Vibes of the Cosmos.
Yeah.
Okay, give me a moment.
I was thinking I would want to stream some, so I might jump on my computer.
Oh yeah, if you have it, yeah, you can share your screen if you have it. If you have it, access to it already. So I did find the channel Vibes of the Cosmos.
Whatever.
I'll search moon in the. So I see compass, moon rotation. Uh, cities a flat world. Cities a flat world on plasma moon.
I'm gonna pull it up for you.
Okay.
But yeah, I would say this was definitely put me over the edge.
Interesting. And Real Kindness in the chat says, "Pull it up." I think that comes from this flat Earth proponent named Ross. He always says, "Pull it up." Ironically, though, I talked with him once. He's kind of reluctant to pull it up when it's him pulling stuff up. It is on my channel, and then I found he doesn't read the stuff that he references anyway, which is, of course, almost like that is one of the laws of flirts, I believe. It's awesome. So I will screen share here. We'll see what this image is.
It's working.
Yes, it is working. I see your cell phone. I see Vibes of Cosmos with the videos,
Hey
right?
there. I know you're in the middle of something, but I was wondering if we could just take a few seconds and read some scripture.
So this is a video titled, so we see the moon on the left in two different orientations.
I clicked a random video. I'm hoping he does the overlay. Okay, so this image on the right is something he made out of an image of the moon.
Okay.
I want him to show the process where he does that. So that's not it.
And Real Cogniz confirmed the first law of flirt with their references.
Yeah, typing the word flat earth in on that's not going to help me right now. All
Yeah, I
right, just give
noticed.
me 1 second. Let me find
Okay.
it.
I think they did do some kind of,
But
go ahead.
I'm going to find the actual video that I watched.
I did find this. Let me, this thing called Moon Transition to Political World Map. I'll
Yeah,
put it in. I'll put it in the chat if you want to load this one and see if that's the one. Uh, it's in the chat inside the stage. Maybe it's to the right of the stage. I guess I don't know where to be on the.
thanks. Yeah, you found it before I did. Okay.
Some well, if you're on a cell phone, it's probably just easier for me to type it in on my computer. Is all it is.
Yeah. All right.
Awesome. So this is the actual one. This seems to be it.
This exact moment was for me, I was like, "Oh, I see it," you know. But you have to have a doubt in the government in the first place.
That's right. Heavy in the position is, the government is lying and all the scientists are either in on it or being tricked and can't trust what they say. So just fed into the conspiracy thing as well.
That's right.
Man. Okay. So this had you over watching this video here, and it was this part right here where it shows it looks like it's not even covering the whole moon. It looks like all the planets are just in that lower right section there, right? I mean, all the continents are in the lower right section there.
He's doing the political math. So
Okay.
he's saying that's Africa. Yeah, he's saying right there is Africa.
By the way, what is this supposed to mean though? Like, what is this supposed to communicate? That
So
means
I'll
that the
tell you. I'll tell you what flat earthers don't really like to claim. But the reflection of the deep is a quote in the Bible somewhere. I think somewhere it says something about the moon being a reflection. There's all the lore and all the mythology about, you know, Greek gods in the sky. The moon is referred to as a reflection in a lot of this stuff.
hmm, interesting. So it is a biblical thing, which I tried to ask Witsit about. I've heard him before in his, I don't know, I don't remember where it was at, but I heard him before say something to the effect that it's very religious. Even though he didn't admit to it then, he said even if the Earth was a globe, it won't affect his God belief. But it certainly seems like for several of them, the Earth being flat and their religious belief is totally intertwined. And you pointing out this is one of the evidence, even though some of them may not claim it, of the Bible having a say in the Earth being flat, because I guess it's sort of as above, so below type deal. That's fair to say.
Yeah, it's if you were to try to make sense of it in any way, the Bible indicates things that might get used in a flat earth model. That's all it really is. Face of the deep,
Interesting.
the four corners of the earth, the pillars of the earth, the end of the heavens, the frozen heavens, like all these references to the sky. It's like, oh, it's saying that the heavens are frozen. So the sky is a super solid, helium super solid, and light, the lights in the sky, the luminaries really are just lights in the sky, like in the fluid medium of the frozen helium. And that's what the
Interesting.
stars are, right?
L-
And all these like planets are orbs. They're like the result of electromagnetic something. I don't know.
And what is your background as far as science and math, by the way, at this point? Like, what was your, like, how much formal training in like math and science did you have at this point?
When I went to college, I went ahead and I took English and philosophy and debate. So those that was my that was my 2 semesters. And then I went right back and then I went right to work. So
Okay. So this
that's what I did
period.
when I went to college. So
Oh,
yeah, my geometry is all like my understanding of geometry is all after high school. So it's
awesome,
not
awesome.
college level. It's just like me trying to understand geometry. Yeah.
I got you. So basically, this was after you had 2 semesters in college, went to work. After that, you found the flat Earth,
That's right.
right?
So like I didn't take any math courses when I went to college. Like all my understanding of geometry in high school, that's what it was.
Right.
And whenever I try to learn geometry post then is like, building on that.
Good. Now, hearing you speak, you sound like an intelligent guy. So at the time, it seems like just lack of awareness, just ignorance of science and math that allowed pseudoscience to fill that gap. So I mean, this seems to be very consistent with those who come into flat Earth not having a solid science and math background, but it's understandable if you think that all the science and math is part of some kind of sham or deception, right? Because you mentioned there was the whole conspiracy aspect of it where you can't trust the science and the math anyway, right?
Well, trusting science is a funny quote for me because, I think about the pharmaceutical industry immediately.
Mm,
But besides that, um, there's a lot of things that, if you're interested in flat Earth and you're looking into it, there's a lot of aspects of science that people believe support flat Earth. So they don't think that math contradicts flat Earth. Like their investigation on satellites and geostationary reference frame. I don't know what's going on with satellites. At some point, it's like you dig, you dig, you dig, and then you find ways to, you know, uh, reclaim flat Earth.
mm. So, what would you say is the strongest or most prevalent argument you can remember uh, that
Oh, but
science
there's something.
supports
My
flat
bad.
Earth? Go
Can
ahead.
you remember that question? Just
Certainly,
remember that question. There's one.
certainly.
There's one thing I wanted to say.
Okay.
The math for the prediction of the amount of mass in galactic clusters, like galaxies are moving too fast. So the prediction for dark matter or whatever is, you know, you have a fascination in astronomy and you watch shows and you're just trying to build on your cosmological worldview. And they're telling you, hey, this prediction right here is wrong. 83% missing mass. So as a flat earther, you might say, hey, this right here supports a flat earth,
Mm,
right? You have the axis of evil. So they claim the cosmic microwave background that there is like a preferred direction for like all the galaxies in deep space. And they call it the Copernican principle, where either we're in the center or everything is expanding and it just looks like you're in the center. So in a weird way, you reify flat Earth by saying, hey, we this apparent observation of it looks like we're in the center and everything's moving away from us. That is what's actually happening. So it's just reifications right there. And
okay.
that goes on. Like the more you look into like our understanding of cosmology and deep space, there's funny ways to reify flat Earth. That's just what ends up it looks like sometimes.
Hmm. Now,
Our understanding of general relativity, special theory of relativity, and curving space time. And some people think that that just sounds funny.
right.
I mean, does everybody truly take the theory of curving space time at face value?
I'll tell you what. Let me go through each of these. I myself, I'm not an expert at science or physics. I'm learning, but I am a senior, double major in physics and astronomy. So I would say I have more basis of it than the average person. And I do want to give the full explanation of these for the audience as well, in case a flat earther is watching as well. I do see at least look like three are watching now. I don't have a big audience. Two are commenting. Thanks for y'all for dropping a line. All right, let's start with dark matter. So I'm aware that flat earthers say that the dark matter thing means the model is not working. Are you aware of how? And I mixed up the planets. Are you aware of how Neptune was discovered?
Oh, you would have to remind me. I'm
Right,
sure I've looked it up before.
right. So if you look into like older astronomy, they knew six planets. What was it? Mercury, Venus, Earth, Mars, uh, Jupiter, Saturn. That's the ones that they knew because those are pretty easy to see. I mean, really, you can see those with your naked eye if you have good enough vision. I mean, you can't see any detail, but I mean, you could see them. I brought my telescope out to find them, and I was able to see them in the sky before I pointed my telescope at them. But that's what they knew. So when Kepler came along and he studied the detailed observations of this guy named Brahe, like his name was, But this guy made some detailed naked eye observations of the solar system. I mean, detailed, precise, and probably the most precise eye detailed observations ever made. And Kepler got a hold of that data and he studied it meticulously, and he came up with the equation p squared equals a cubed, meaning uh, uh, the period of a planet going around the sun squared equals the distance from the sun cubed. He was able to use that formula to precisely map and predict all of movements of the planets in the solar system. Now, when Newton came along and we started to understand gravity, we were able to bring this equation to the next level by dividing the right side by the total mass of the system. And that allowed even more accurate predictions. So what happened is they were mapping all of these planets. They knew of the six that they knew, but now they had a more accurate mapping of it. But then they realized that the timing for the outer planets was a bit off. At this time, I believe they found Uranus with its satellites. So at this point, Uranus was included. The same p squared equals a cubed. But Uranus was the specific timing of Uranus was not meeting the proper times. But what they realized was the timing matched if another planet was there. So they did their calculations and they figured out where the planet should be. They pointed their telescopes there and they found it, Neptune. Right? So when they were getting the
That's
incorrect,
badass.
yeah, look it up.
Shout out to them, too.
Yeah. So my question to
Yeah.
you is when when they were calculating Uranus and they were getting incorrect values, does that mean that the map was wrong or the model was wrong?
No, clearly not,
No,
because they ended up finding. Yeah.
exactly. It was so right that it pointed out something that was there that they wasn't aware of. Now we go to dark matter. The same thing is happening. We
Do
understand
they
how
claim
gravity works. Go ahead.
what is the claim about dark matter in galactic clusters
Well, it's the
and
same
with
exact scenario. It's the same exact scenario. We're looking into space. We know how matter responds gravitationally. And we're looking at stuff and we're saying, hold up, that's not behaving properly. But if there's a mass here that has this amount of mass there, then it does behave properly, right? And then what we can do is the mass is so great that it would actually bend light. We can calculate this. The mass is so great, it would actually bend light so that it will make a lens out of light. And lo and behold, if we point our devices at these pieces of sky and use our calculations according to how the gravitational lensing would be, if the mass was there like we calculated it should be, just like how if the planet was there like Neptune is there, it matches. And that's how we know dark matter is there. So this is an example of and I'm about to share my screen momentarily. We find the proper slide, play slide from current slide. Here we go. So what you're seeing here, this is a slide from the presentation I did on Sunday. It actually comes from a talk I did on dark matter. I did the talk a few places, but I also did the talk on MC Tunes channel. So if you go to MC Tunes channel, you'll be able to see it in detail. But are you able to see that image right there with the green circles?
oh yeah, I can see it.
Okay. So the orange red in the middle, that's plasma. And the plasma weighs, it's been a while since I looked into it, but it's about 7 times, if I remember right, more than the mass in the galaxy. So basically what we're looking at is, I'll back up a slide. We were looking at this galaxy cluster right there. So that's it's hard to see here, but I only have so much time in the presentation, so I couldn't put all the slides that go to it. But what we're looking at here are galaxies. Each one of those things that looks like stars are galaxies. And what happened is these two galaxies collided and started going past each other. But the plasma being sort of, liquidy like, clung together just like drops of water in the middle. So we're looking at theory of sort of the plasma is in the middle, which is the majority of the mass, and the actual galaxies went to either side of those. And now what's going on is we see that the lensing is to the left, which is where the galaxies are, which we know the mass of the galaxies we can see is not as much as the plasma. So there must be some mass in galaxies that's more than the mass we can see that's causing all the gravitational lensing to focus at that point. That's what we call dark matter. So when it comes to Neptune, we could point a satellite at Neptune or a telescope and see, okay, there's Neptune, that's a planet. That's what the mass was that was causing our calculations to be off. It just so happens with dark matter, we can't see what it is. So just like how we know Neptune is there, we know something is there, but unlike Neptune, we can't see what it is. So we know that there's something there that's causing a gravitational effect, but that we can't see it like normal matter. So since we don't exactly know what it is, we call it dark matter. So dark matter is not an indication that the model is not working. It's an indication that the model is working so well that we can find something that we can't see, but we know is there because of the effect it's having gravitationally. And those contours that you see in green, that's literally the gravitational lensing contours. And you could look online for other gravitational lensing images, and you could see how some of them they call an Einstein ring after Einstein because it looks like a circle going around a certain area because the light is bending. So that's just one of the misunderstandings that flat earthers pass on. Um, Looks like in the center. So in my I took a class in the spring called Galaxies in the Cosmos. I remember. I don't remember the exact name, but it's something like that. But it was a class on the large scale structure of the universe. And our professor did something very interesting. She took and she this is what she does, and that's the thing about it. Like these people in colleges and universities, this is what they do. Like I hear people like I didn't. There's so many things I could have addressed in that talk with Whitsitt on Sunday. There were just not enough time. But one of the things he brought up was this whole talk. You probably heard it before, where they talk about dynamics is this and kinematics is that, and I don't know who started this nonsense. I never heard any scientists in the class I talk about mention that difference in the way they do. But the people who I take classes with, they build the devices, they make the technology, right? They make the cars, build the buildings, make the cell phones and the iPads. They make the stuff. Right? So you have a group of people that's literally building the technology we use. And then you have this person over here just talking a whole bunch of stuff with no technology, no laws under their name, nothing. Okay? So I say that to say these are the people who pointed this understanding out to me. This is what she does. My professor is one of the leaders on an international group that studies space with, I mean, she did a presentation on it. It's pretty complicated, but like she travels out of the country leading a research project. She knows what she's talking about. And she made this
Hey, hey,
diagram where she had like a
hey.
whole
So let me
bunch of.
say something, dude.
Oh, go ahead.
Yeah. So people with an interest in cosmology and astronomy, and clearly, like you said, you went to school. You just did your exam. You're like fully immersed in the subject. I would say. I think that what you're showing me, what you just showed me, is awesome. I love that
Awesome.
stuff. Thank you.
You're welcome.
For somebody that's new to the subject and they're not going to school for it, and they're watching, they're just watching and they're reading stuff, and they see something that says 83% missing mass, or dark matter is a quote unquote placeholder, and they're trying to make sense of that. And what you tell me is fine. I think that I can wash my hands with that. You know what I mean?
Okay.
Okay. But not everybody gets to talk to you. And not everybody looks at things the way I do, which is kind of weird if you ask me. But I think that it's not everybody's fault. It's not their own fault that they philosophically interpret cosmology a certain way, when they hear like these big talking heads for the cosmology in documentaries saying like we have a placeholder called dark matter, and we don't observe the amount of mass required to accelerate these galaxies. However they like translate that to people's heads, people take that as we don't observe mass in the sky. Like there's not enough galaxies. There must be some kind of creator, some kind of intelligent designer, where the amount of mass is not what causes galaxies to cluster, but there is some kind of fine tuning thing going on. And I'm sure you've heard the fine tuning argument before. But yeah, I'm just, I'm not really telling you that's how I feel. I'm just being sentimental towards that. So
I see what
however
you
you want
mean.
to take that,
I
yeah.
see what you. I remember there was a period of time. I guess this had to have been around 2018 or 2019 because somebody I knew personally had gotten into flat Earth, and one of the arguments he made against me, he said, is the moon in the Earth's atmosphere? Right? And I'm like, no, of course the moon is not in the Earth's atmosphere. And he says, well, the scientists say now the moon is in the Earth's atmosphere. And I mean, two things. First of all, it was a dishonest question because the way he worded it, you're thinking like an airplane or something. And secondly, I knew when he said that the article he was referring to because I saw somebody make the argument and I looked it up. A scientist had made a discovery that uh, there's a field of hydrogen atoms around the Earth that extends way past the moon, but it's like one hydrogen atom per like 100 cubic cubic meter or something. It's something kind of infinitesimal amount. But to your point, the article did say, and I tried to find that article before this last debate. I couldn't find the exact one that I was looking at, but the article did say something like, scientists find Earth is in the moon is in Earth. They worded it in some kind of crazy way where it goes exactly
Yeah.
to what you're saying. Yeah,
Okay. I'm with you.
yeah, yeah.
Yeah,
So I
some
mean,
things are sensationalizing when
there
it
you go.
comes to like journalism.
That's right.
Yeah, how are you gonna hook, line, and sink a reader? Yeah, I
That's right.
get it.
That's right. That's right. And that's the precise word. They sensationalized it. So, I see what you mean. So somebody who's just already chomping at the bits about a conspiracy and not trusting the scientific regime, and then they see this like, hold up, all this time they've been
I think
telling us
they're
the
fun.
Earth isn't. Go ahead.
I didn't mean to interrupt you. I got
No, go ahead. It's
excited.
okay.
I think they're farming the distrust on purpose. I mean, they do things to people that they know that regular human common sense thinking people will object to, and they just do it, and people are becoming distrustful. That's it. It's like, how do
Now,
you explain the amount of distrust accumulating in the people?
now I can tell you based upon my experience working with physicists and astronomers, I can tell you that they don't do that. In my experience, I don't know how much you've interacted with them, but like I work as a learning assistant. I work pretty closely with physicists. For the last 2 years, almost all of my classes have been physics and astronomy, since that's my major. And just like anybody else, they need funding and things like that to get things done. So I can tell you that the person who wrote that article, from my experience, he wasn't trying to deceive anybody or fuel some kind of conspiracy. He was just trying to make a catchy. One thing to keep in mind, by the way, and I hear this come up a lot. Like flat earthers might say, well, why did they put a camera on the thing that pointed at the earth, and why did they put five? Like they bring up things to say why don't they do something to prove the earth isn't flat? But let me let you know that majority of those people are not thinking that at all. Like when I go to my astronomy class, they're so far beyond thinking about trying to disprove the earth being flat to people that it doesn't cross their mind to fuel any kind of conspiracy or anything like that. It's just, the people that actually build the rockets, they know the Earth is not flat. They're not thinking about it's so like the people at SpaceX know the Earth is not flat because they shoot rockets around the planet. So it's so far from their mind. Like when if they did a sensational press release they're just trying to get attention on the stuff they're doing. I can promise you that from my experience. But I can certainly understand from somebody who sees it from that perspective how it can fuel that. And I don't really know what's the solution to that, right? Because the fact is, nowadays we're in a society where people, unless the headliner captures them, everybody has like a 10-second, attention span. That's why Twitter was so popular, right? You could only write like 100 words or something or letters. Like that seems to be like the ongoing attention span. You have to either hook them in the first 5 seconds or they're on to something else. So that's all it's about. But to your point, it doesn't help when somebody's has a perspective that lends towards the conspiracy, and now on their end they're just
I
being
don't think
sensational. Go ahead.
I don't think the distrust in government should bleed into astronomy. Personally, I think that anybody could go get a telescope and make these observations of Jupiter's moons
To a
casting
point.
shadows on Jupiter and Saturn's rings. Like, how do you explain Saturn's rings? If Earth is flat, why do we still observe like mass becoming spherical in space?
So
Like, you're
let's go
saying
there
mass
next.
can't become a sphere in space. Yeah, like that's how I feel. Like
Well,
astronomy, you shouldn't distrust the government and say that they're lying about astronomy. Anybody can do astronomy.
that's right. So let's go there next. Like, what is your take on that? Because you were in the flat Earth community. At one time, you believed the Earth is flat. Yet, like, did you get a telescope
Well,
and
I had a telescope when I was younger. I'm not a professional astronomer. I'm nothing like that, dude.
mhm.
But I do love astronomy, and I care to understand a lot of aspects of it. And I love what you explained about Kepler and how we discovered Neptune, man. That's fucking solid. The way you put it together is really great.
Awesome.
Um, yeah, I
Well,
wish I had a telescope. I'd use it all the time right now. Like I would mess around with all that stuff for fun, but I don't have any of that stuff. But
now give me
what's
a
it called?
moment here. I see some people in the chat. More people are joining. I'm glad y'all appreciate the conversation. Let me actually put the link to the Discord in the chat, and me and Kali will still talk for a bit. But if you want to join, so I'm not spending as much time this time looking at the chat as we get our talk going. But let me go ahead and I'll read through some of the chats, Kali, in case you want to respond to some. So I'll scroll up
Okay.
and I'll go back to where I left off at. Um, Let me see. That's why issue. Real Cognitive said Big Pharmacy is indeed douchey and government related, but it doesn't represent academia. What do you say?
Yeah, that was my sentiment as well. It doesn't represent all of academia. There's institutions that claim science backs everything that they do for their business profit.
Hmm.
And that's not always the case. There's people that lie about their science, that like this medicine is going to do what I claim. And then all of a sudden, we got to recall all our medicine. So that happens all the fucking time. They lie about what they claim is science.
May
But
look at
that
the
I
side
don't think you
effects
could
that
lie
COVID.
about much yeah, I don't think you could lie much about things people can do independently.
That's right. Like you're saying with the
Like
telescope.
there's a flat earther named Dwayne Kellum. I'm glad I learned about this guy because I think he's awesome. And he went ahead and he put together his own balloon and he sent up his own instrument package. He had like a pressure reading device to get his altitude, and
Okay.
you know he had the right camera to reduce distortion, and he observed the curve of the Earth.
One of the best ones I've seen, by the way, is Rob Skiba. Rob Skiba was trying to prove flat Earth, and he sent up a balloon and did really well. And he found the curve of the Earth, and he admitted that he found the curve. That the video is on my channel called Rob Skiba's Butt Growing Proofs for Globe, something like that. He also like made a to scale rendering of the Earth and the Moon and the satellite around the Moon, and showed that the sizing was accurate. Real Cognitive says, as far as the CMB's axis of evil, there was initially some unexpected alignments in higher order quadrupole bimodal polarizations or something, but with ecliptic, not Earth tilt. I'm not sure
Sounds
about
like
that
you
one.
know more than me, man.
Yeah, yeah. I
I've
think he
never
knows
heard of
more.
that. Yeah.
Yeah, me either. Yeah, yeah. Which I probably should, because I took astrophysics and we talked about the CMB, and in the class I was telling you about last night, we talked about the CMB, but not in detail. But guess I'm not really big on the CMB. Uh, 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 Catherine
What is
says,
the thing about the CMB that convinces? That's what did they say about the axis of evil? The
I'm not
Copernican
really sure,
principle.
ironically. The first time I heard that phrase was Sunday when I was debating with it. And, um, I still don't see what the big deal is. I mean, it ties into to the thing about the center, right? Like that example my astronomy professor did, she put a lot of points on the board. Like she had a program that moved all of these points away from each other at the same rate. Like all these points are moving away from each other. And then she would center on one point. Like she would center on that point and keep it fixed on that point. And all the other points moved away from that point. And then she would fixed on another point in the same simulation, and all other points moved away from that point. So it's just that our understanding is that from any point you pick, every single point is moving away from every single point. So, like somebody has said in one of the comments to the debate I have with Witsit, you can't use something that works for every single point as evidence for one point, right? So if the CM
Okay.
and the CMB itself disproves flat Earth, because the CMB, I remember this much. Basically, the when the universe exploded in the Big Bang, there was a whole lot of energy, and that energy was very, very hot. And as the universe expanded and it cooled down, the energy of the CMB, that is that energy that cooled down to, I forget the exact frequency, but it's just an energy that's everywhere. That's a result or a leftover from the Big Bang. And Kali put up a image here. Let's see what it says. The axis of evil in the context of the cosmic microwave background refers to an anomalous alignment of the larger scale fluctuations in a CMB, which is the afterglow of the Big Bang. That's what I was referring to.
Exactly what you just said. Yeah.
hmm These fluctuations are usually expected to be randomly distributed, as predicted by the standard model of cosmology, specifically the inflationary model. However, the axis of evil describes and observed phenomena where these fluctuations appear to align along a particular direction in the sky. And this is from ChatGPT, like you asked ChatGPT.
Yeah.
This alignment was first noticed in 2005 by analyzing data from the WMAP satellite. The term axis of evil. Now, here's the thing. Whatever conclusion we draw, do flat earthers now accept that the Earth is a globe with satellites orbiting it?
Oh, I know. I don't know exactly how that argument goes. It has to do with like treating the Earth as like what did they say? That you need some kind of reference to be fixed for satellites. So Earth is treated as like a stationary reference for satellites. Like satellites have to treat like there is a center of the Earth. I
No,
don't
no,
know what
no.
it's called. I don't know,
No,
dude.
no, no. I don't mean anything even so complicated. I don't mean anything even so complicated. Like, in other words, any flat earther who's arguing the axis of evil, according to this, they're arguing a conclusion drawn from data from the Wilkinson Microwave Anisotropy Probe satellite. And we know satellites, according to the the establishment explanation at least, is that they orbit the Earth. Now, I've seen the space station and I know it orbits the Earth. I've seen satellites streak across the sky. But I'm just saying, the idea of using information that's wrought from a satellite contradicts the idea that the Earth is flat. Just the fact, it's kind of like if I was,
Have you heard that argument? It's not my argument. I'm not bringing it justice at all right now. I feel bad for anybody that ever tried to make it and they're hearing me butcher it right now.
no, no,
But
I've never even, I never
but
really,
yeah, apparently, yeah. I think you know what I'm about to say.
no, I don't. What?
Do they treat Earth as a fixed? Like, okay, so what does it say? It says something about it. I don't. It's a reification that Earth is stationary. I don't care to make the argument, dude. I don't
No
even know
problem.
it that well.
I'll read the rest of this though. The term axis of evil was coined somewhat humorously, reflecting the unexpected and troubling nature of this alignment, because it changes the cosmological principle, which states that the universe should be isotrophic, the same in every direction on large scales. There's an ongoing debate about whether this alignment is a statistical fluke, a result of some uncorrected observational bias, or an indication of new physics beyond the standard cosmological model. Well, I haven't come into that in any of my classes. I've heard people mention it, but uh, uh, I guess it brings up something that somebody had put in one of the comments of the debate. I guess this might communicate it more clearly that perhaps we should make it so that the globe side can't use any sources of data that come from something flat Earth, which we never do anyway. But the flat Earth can't use any sources of data that come from globe. Like if it comes from a satellite that's orbiting a globe Earth, then you can't use it. Let's see what the next comment says. Somebody after that, Catherine MC said, "Wow, oh my God, that's amazing." I'm not sure at what part though. Maybe it was talking about the discovery of Neptune. Let me turn the timestamps on. Maybe that'll help. 9:22. Yeah, I think that was wrong when I was talking about discovering Neptune. If you Derek Bradley says, if you can't see it, then how can you
I'm
see it?
I'm trying to make ChatGPT admit that Earth is flat right now.
So so the idea, Derek, is you can see the effects of it, just like how we can see we saw the effects of Neptune before we pointed our telescope at it to see it. We could see the gravitational effects of dark matter even before we identify what it is.
Right.
And what's
I
another
agree.
one? Uh, Whirlpool washing machine, the corporated space shines, and no, the Discord is not commercial. It's what it is a community, so you
Oh,
might
can
have
I
to do a
ask you
little
a
intro
question?
thing. Right.
Do you feel there's okay from a completely hyper like you have to be like hyper rigid, like super critical? Is there anything anomalous about our understanding of Earth's cosmology right now? Like, do you feel like there's something as a placeholder at all?
And what was the first part? Is there something what about cosmology?
Anomalous, like misunderstood?
Of course. I mean, we don't understand everything. I mean, that's a given. That's why there's still more to learn. So the reason why, in order to get a PhD, you have to do unique research. Either you're getting your independent data yourself or finding something new in someone else's data. Just the fact that we have dark matter, we don't know what it is. There's dark energy. We don't know exactly what that is. So there's many things that are unknown, right?
Right.
What else
Yeah,
on that?
that's what's interesting, you rarely get a chance to what's in the hearts of astronomers, right? Do they feel like that God is necessary somewhere in all these equations?
No, no. I mean, that's not the. When I say that, I say officially. Like in other words, I'm sure there's astronomers that believe in God, but I'm saying you're not going to find an astronomy book that says, "Well, we don't know what it is, so God did it." That'll never be there. So, the idea of science is to find an explanation that's that's built on natural, observable, reproducible laws, explanations, and so on and so forth. So the understanding of science is that everything in the universe is explainable in a rational and way that we can quantify mathematically. Like for instance, gravity. You can go to any planet and apply Newton's equation. The value you get for G will be different, like on the moon versus Saturn or whatever, but the same equations work anywhere in the universe. All you have to do is get the mass of the body you're on and apply F equals G mm over R squared, And F equals ma, you'll get the acceleration, and you drop something, and it'll work. Just like how they dropped the things on the moon. When she tuned to the analysis, it dropped as fast as it should with the mass of the moon. So there'll be a period of time when we understand what dark matter is, I have no doubt. But then we'll find something else, most likely. I mean, what is the universe in? I mean, what is how small can things be, and how large can things be? We don't know. So I think the misconception that flat Earth forwards as if it's a strength is the idea that if you don't know, then something is absolutely wrong with the system. But they say that without presenting anything. So, like, in other words, how many, in all of your time of being a flat earther, when you were a flat earther, and even since then, how many times have you seen a flat earther predict the next solar eclipse using their flat earth knowledge?
Oh, I don't think Earth is flat.
I mean, I know you don't think now, but I'm saying, like, I mean, even from when you were and now, just thinking back over all your time from before you were a flat earther, when you were a flat earther, now, when have you ever seen a flat earther predict using their flat earth knowledge when the next eclipse will be?
Well, the most put together thing is Dave Weiss's app, I think. I don't know if there's a different.
No, I'm asking a very specific question. When have you ever
What do they
seen either of
claim?
them?
Magnetic holography can cause eclipse. I don't know what they claim
No, no,
can
no.
cause
Listen,
an
listen to the
eclipsing
question.
of the moon.
I'm saying, when have you ever seen any of them predict with their flat earth knowledge when the next eclipse will be?
No, I don't think flat Earth can predict eclipses.
There you go. So that means never. So that means that the globe understanding at least has that. And if you go through every single thing that the globe can do and the flat earth can do, you can see that flat earth can't do anything, and the globe can do a lot of stuff. So the fact that the globe that we don't understand everything is not a slight to our understanding. It's just there's more to learn. We don't know everything. We're willing to admit that. But I understand that there seems to be one of the biggest draws of flat Earth is saying, look, they don't know that, and it's like, aha, they don't know that, and then it's like down the rabbit hole. Let's see what the next
Well, yeah,
thing
that's
is.
something I wanted to mention a little more about was
Yeah, go ahead.
the motivations, like when you initially learn about like the flat Earth topics that get thrown around a lot.
Okay.
Things about like Gauss's law, things about Coulomb's law, things
Mm.
about like three body problems, and NASA claiming in documents that like certain means of flying, we treat the Earth as a stationary reference, like all that kind of stuff going on, and then being able to like I said, like with holography, apparently you could like somewhat model stars and planets with holography. So like you got all these little bits and pieces laying around that you kind of got to put together. You know what I mean?
Okay.
And supposedly math supports all these things. You know, like the idea that there's things in flat Earth that don't work. When you first get interested in it, it looks like when you're first digging through all the topics that math does support flat Earth. Like all the ideas about is gravity a theory? You type in "is gravity a theory" on Google right now, it's gonna say yes. So therefore it's not proven, and
I
then
got
all
you.
that deductive reasoning goes on.
Do you
What else?
understand
Gauss's
what's meant
law.
by theory now,
You,
though?
you look into. Sorry, say again.
Do you understand what's meant by theory now, though, when they say a scientific theory?
Say again.
Do you understand now what is meant when they say a scientific theory? Like, what does theory mean?
I always knew what it meant.
Okay. Like, what would you say it means?
It's evidence. There's evidence of something, of a phenomena. We observe a phenomena and try to explain the cause and effect.
It's even more than that. So, if something is a theory, that means it actually has the highest level of evidence behind it possible in our understanding of science. So there is like a theory, like I have a theory that you know, unicorns all have one horn, right? That's like a hypothesis, right? But
Yeah.
when you see the word theory in like a science book, what this is saying is that this has been tested so much by so many people in so many different scenarios that we are as close to knowing that this is absolute 100% truth as we can anything. That's what theory means. So when flat earthers say that, either they're just mistaken or they're lying. The ones who promote that idea of theory, like,
Yeah, I use the word reification a lot, but
hmm,
it is a reification when you say, "Oh, look, Google says gravity is a theory." That's reifying flat Earth.
yeah, I mean, I've seen people use it. It's
But
just that,
besides that, it's just the go ahead. It's just
no,
the
go ahead.
idea that you know you look up Gauss's law of magnetism and then Gaussian plates, and then there's like all these little snippets. Like you got to gather all the flat Earth evidence. You got
Hmm,
to find all the snippets of information that supposedly support the claim.
I got you. And that's
And
just one of the
it's
ones.
like videos and like certain citations about radar, certain citations about infrared cameras, and you know you got to talk to the right people that aren't gonna like just make the entire debate about flat Earth being wrong. Like, look, flat Earth is definitely wrong. That's it. We're done. Like, no, there's people that want to like talk about little discrepancies, and maybe there's like tiny little things that we don't fully understand about the world,
All right. So let me
right?
get through the chat, and then let's go into how you got out of flat Earth, and then we'll start the head to wrap it up. So let me
Oh
start
yeah,
from where I left
that's my
off.
favorite stuff to talk about. That
So
is
let
my
me
favorite
finish
thing
through
to
the
talk
chat
about.
this time. So they're pretty good at what? So I'm not sure what he meant by that. The man says, "How a planet in relation to the sun?" Yes. All their strong. Oh, yes. So Catherine was saying, yes, the math and the science of how the planets move in relation to the sun. She was saying that was awesome. Thanks, Catherine. And
Yeah.
Bird says, was asking, so there's like a mini conversation going on in the chat. It's trying to do. All right. So Derek said he doesn't want to join Discord. He's just giving the chat some push. And Catherine also says the galaxies and the photos in the plasma. Yes, look up the bullet cluster and look up. I mean, there's a scientific paper, some serious reading with Clow et al. I'll put the name. His name is Clowe et al. And that to me is the biggest evidence for dark matter. And I'll put it in our chat as well if you wanna check it out. So et al. Bullet cluster, and it's the evidence of the gravitational lensing of dark matter. And let's see, this core showing the curve. And Derek says GPS determined the shape. A computer coordinate system determined Earth shape. Right. So I guess Derek is a flat earther. Uh, what was before? Right. So Derek says, surely you didn't think predicting sky rotation means you figured out the Earth shape, Darryl, do you?
What?
You go watch my. I want to try to keep it along the lines of the discussion I'm having with Kali. But if you want to just have a strict, how do we know the Earth is a globe? Just look at the debate I had with. Look at my opening debate that I had with Witsit, and my time kind of ran out before I got to the clincher. But I explained it a bit further, a little bit to the debate. So pretty much, if you watch the first 30 minutes of the debate, you'll be able to see a good explanation of how we know the Earth is a globe. At least one of the ways we know. And Derek said, you say globe, you're talking about the Earth or the celestial sphere, or do they overlap? So the globe, when I say globe, I'm talking about the planet. The celestial sphere is just an interpretation of how we see the sky when we look up. But there's not really a sphere around us. We just sort of interpret it that way and sort of just imagine all the different stars, even though they are different distances from us. All the visual stars we can see with our eye, we just imagine like we punched a little hole in a little sphere around us. But it's more of a convention that just stuck around. But apparently, when the term first came up, they really believed that, but we don't think that anymore. Where Cognitus said with retrograde, aberration, parallax, and Doppler shift, it's automatically off the table, a dropout said. So I think he's referring to the fact that, like I've talked to like, what's another one? Oh, So, Kylie, one time when I was first talking to flat earth believers, I talked to this guy. I was joining this Discord server, and he said, "Well, before you get into the voice chat, we need to ask you some questions. We need to give you this little interview or whatever." And he asked me, "Well, what evidence do you have that the Earth is a globe?" And I said, "Well, I mean, we have satellites in space that's going around, and it took a picture of the globe. I mean, it's pretty straightforward." And he says, "No, give me some evidence that we can see, some tangible evidence we can see." Well, I forget his exact word, but it was something like, "We can see on the ground, not something. Have you ever been to space? Are you in space right now?" So basically, he was just he was setting the restriction that I can only answer in a certain way. And I've seen them do that,
Yeah,
like
he wants to experience space when he's on the ground.
something like that. Like yeah, basically, like whatever. It needs to be something he could tangibly touch right now. But of course, if you keep limiting it and limiting it, well, I can't mention that because that doesn't fit. Then it just wants you to get to the point where you say, "Oh, I don't have anything," because they just basically randomly, biasly, just dismissed everything. But of course, I didn't fall for that, and he just booted me off. So I wouldn't play his game. Um, but that goes to something Real Kindness was saying. And Splurge says Earth is an oblate spheroid. That's right. Lisa says a theory. Oh, what's going on, Lisa? How you doing? A theory not only encompasses evidence, it also predicts future measurements. It's far stronger than just evidence. Yes, theory is going. Lisa is going back to what I was saying about a theory. But I know
Yeah,
flat
theory is
earthers.
not just evidence. That's right. Yep.
Yeah, it's. I mean, it's been tested over and over again. It's made predictions. It's like gravity. It works. So it wasn't until Einstein came along. I don't remember when Newton was what the 17th century? Yeah, yeah. The 17th century was Newton, and Einstein is the 20th century. So that's what 300 years. 300 years, gravity stood unchallenged, and it's only when things like the because Mercury is so close to the sun, is very close to the gravitational field of the sun, so it does experience relativistic effects in its revolution. So the revolution is not like any of the other planets. It's sort of it goes around, but it also spins like it wobbles, almost like a clock, like a spinning top. And we can only solve that with relativity or gravitational lensing. That's why they call it the Einstein ring, right? So a few things are named after him because when you start to get to that level of that much gravity, it takes relativity to really pin down the revolutions of things and stuff like that. But something's going really fast. Like in my survey class, when we had to calculate if a spaceship is going from here to wherever, and another spaceship is going from there to there, we have to calculate the time difference between the two, like the time they will experience on the clock on spaceship A versus spaceship B. That takes relativity. So until you get to stuff like that, gravity works, and it still works on that in the um, domain that it fits in when it's not too small. Like,
What is the? Can I ask?
go ahead.
What is the unit? Like, how small is that length of time?
It's a good
The
question.
difference between the rockets. Yeah.
Uh,
Like, what is it
uh,
like?
uh, uh,
Nano something or?
well, I don't remember the answer to that question off the top of my head from that particular problem. It was like the fall of last year, but off the top of my head, I remember it's about 6 or so milliseconds that we have to adjust satellites in orbit. So the GPS satellites, if we don't
Wow.
adjust them, they will gradually get more and more off. So like every so many rotations, it adds up to about 6 milliseconds. We have to adjust it because they're going so fast. I mean, it's only like 14,000 or something miles an
You
hour,
never
miles a second or
observed an
something.
anomaly there? I'm sorry to interrupt,
Go
but
ahead.
I'm like so curious. You never seen an anomaly there, like the time not matching, like, oh, I'm this high above the earth, I'm moving this fast, like this is how much the time should be off according to relativity. And
No,
oh, look, it's not like that. You ever observed that?
far as I know, it's never been everything matches relativity. The
Everything
only
matches.
far as I
Nice.
know. Again, I'm not, I'm not an expert. I mean, maybe there is something in like a graduate class where I get into some precise detail where maybe there's something else, but far as I know, that there's no difference. And again, the evidence is that our GPS works, right? And that's why I say is important. I notice in the flat earth field, they never hold these people to task and say, okay, you know science and math so well. more than all the scientists, what adventures do you have? Because the cell phone I use is made by those people, them, right? And the TV I'm watching is made by them, and the power plant is made by them. All of our technology is made by them. The gasoline we use is made by them. And but yet these people are saying, oh, it's dynamics, and they have all these different ideas about how things really are. Well, what have you built? What do you have? So like the class that I did, that survey that I did relativity in, that guy, his livelihood is doing experimental physics at CERN, I believe it is, in particle physics. I mean, he does this stuff. So, if there was something in the quantum level, he would definitely would have known, at least to his extent of knowledge. So yeah, as far as I know, it all works. But again, we don't know everything, so I'm pretty sure there will be something at some point where it fails, just like how gravity did. But then we'll have to learn some other theory, like maybe when we finally have some kind of technology that can actually see what's inside a black hole, maybe we realize, wow, inside a black hole there's even another law at place because the gravity is so heavy. You never know. And and I think we've caught up on the chat. So thank you, Lisa, Real Kyginus, Catherine, Derek. Thank y'all for dropping lines, Splurge. Thank y'all for being there. Now we'll start to wrap up the second half of this thing, which is how Kali got out of Flat Earth. So take it away. What would you say? What was the first step that got you out?
I want to close that last chapter super duper quick,
Certainly, do your
just so
thing.
you know. I didn't know what I was gonna talk to you about when I got into it. Like, I don't know, but it turns out that, like, I just want you to just like sympathize a little bit with the idea that it does appear to some that, you know, the globe isn't concrete. It's not as concrete as some people like to just blind faith and just say, oh, let's not look at these little discrepancies. That doesn't make the Earth concrete. Let's just point at things that we think reifies a globe. And flat earthers want to entertain the discrepancies. So when you're not willing to entertain these little things that they think might be a flaw in the globe, they're like, well, what the fuck are you talking to me for?
Well, what's the biggest
There's no
discrepancy?
reason.
We got to address it now. Like, what's the biggest discrepancy you found that you haven't found an answer to?
What's the biggest discrepancy that I haven't found? I've searched for answers for all my questions, and I've had a lot of questions answered.
Okay.
But, something that makes people stuck on flat Earth, I believe, is being able to see too far. And there's
Okay.
evidence of infrared cameras being able to see hundreds of miles. The globe uses refraction to explain this, but that doesn't always feel concrete to people that already think Earth is flat. So the real question is, how are you going to make those people, how are you going to talk to them about it? They don't believe in satellites. All right. You want to say, well, let's just look at pictures in space. Okay. They don't believe in space. All right. Now, how are you going to address that? Right. You got to address what makes them think the Earth is flat, not what you think proves the Earth isn't flat. And that's all I wanted you to sympathize with, I
I
guess,
got you.
after all the weird things I said. But yeah, that's that. And what got me out of flat Earth: celestial navigation and refraction.
Was what?
Celestial navigation and refraction and surveying, and
Interesting.
Jupiter's moons. Yeah,
Okay. Let's work backwards. Jupiter's moon that sounds tantalizing. How did Jupiter's moons get you out of flat Earth?
I was in a debate with a dude named Matthew Learns. It was like a 1 versus 10 flat Earth versus globe debate. And like an hour into the debate, I asked all the flat earthers, I said, all right, guys, come on. What's going on with Jupiter? Like, we observe spherical masses, like orbiting other spherical masses. Like, that's clearly a shadow being cast by the mass. So how do we explain this on a flat Earth? And nobody addressed it. And I was like, oh, that's dishonest.
Oh man.
And yeah, so I didn't like how people don't address that question to me. And then I realized, dude, as a glober, when I pretend I'm a flat earther and I'll LARP here and there just to like trip up a glober for fun, it's entertaining. Whenever I'm LARPing and a glober brings up planets, I'm done. That's it. I can't LARP anymore after that.
Interesting.
I have no answer for the planets on a flat Earth.
That's
Yeah.
quite interesting because flat earthers generally it seems to just call them wandering stars or something like that and just a part of the firmament? Why didn't that take hold in you?
Because Jupiter's moon is casting a shadow onto Jupiter and it's orbiting. So it's physical and it's orbiting, and it's, you point whatever instrument to do spectroscopy, like you're determining what's in space, all right? You're pointing away from Jupiter, that's space. You point at Jupiter, oh, look, something changed.
That's right.
So, like, you either say that's light, it's either light, which would make it a reflection because it's not the source of the light. So it's either a reflection or it's actually mass. There's two options. And saying that everything in the sky is a reflection would make everything have to be projected onto a surface. And now you need a shape of the surface. And now it's just getting convoluted. Now it's just making less sense.
That's right. And did you like yourself look through a telescope, or were the pictures enough from like NASA or the astronomy? Like how did your understanding of the Saturn and Jupiter and the moons around it, how did that come to fruition?
I'm lucky enough, dude. I'm lucky enough that I was in it. I was watching live streams of some, I wouldn't even call these guys amateurs, but they are amateurs, but they do a very, very good job, you know, and they will, show you them enhancing the image of Saturn, like as they're like observing Saturn. They'll
Wow.
like have their equatorial mount literally tracking Saturn, and then they're enhancing the image as they do it. I literally sit for hours in their live streams.
Wow, man. So, and I guess the key point was they were not NASA or the university. These were just regular people that had a telescope and were just streaming, looking at space.
Specifically, I'm thinking about a dude named Tactical French Cat and Bob
Wow.
the Science Guy and Seafoam. Cool dudes.
Bob the Science Guy. Yeah, I'm familiar with him. He makes some good videos.
Yeah, he
Awesome,
tracked
man.
a satellite. When I asked him to find a satellite one day, and he did it live, and I was very
Nice.
impressed. He's good at what he does. Yeah, he
And,
found
and,
a random satellite. It was cool.
and who was that with the satellite?
Bob the Science Guy.
Bob the Science Guy. Oh man, good man. So Bob was part of you getting out of flat Earth.
I was already a Glober at that point.
Oh, okay. I got you. I got you. Awesome. And you said Jupiter's moon, celestial navigation. How did that play a part?
Celestial navigation. Yeah, there's a lot of things that gets presumed about the stars on a flat Earth.
Okay.
You gotta put the stars above a flat Earth, for one. That's not really what's happening on a celestial sphere.
And how did you
Celestial
learn
sphere
about
wraps
celestial
around a globe.
navigation? That's right.
Yeah, celestial sphere does not work on a flat Earth, and they reify by saying that the azimuthal equidistant projection is a flat Earth model, and it's no, that's your equatorial plane is cutting through the half of this, is cutting a sphere in half.
That's right.
So, like on a flat Earth, like half of the stars are under the flat Earth if you're using a celestial sphere. Same understanding as a globe model. So there is no model for the stars above a flat Earth.
And how long was it between the time you first got into flat Earth and the time you started having these realizations?
I was watching that documentary, The Lost History of Flat Earth, with the moon map.
Hmm.
I watched that in 2018,
Okay.
and then I joined a Discord server in 2021.
Okay.
So for 3 years, the reason I was a flat earther had nothing to do with all these things you might hear these guys say about like refraction and satellites, NASA being liars and all that. I didn't hear any of those arguments when I was first a flat earther from watching Bro Sanchez.
Interesting. And
Yeah, those were not
2021 is when you
reasons I
got
was a
out.
flat earther. Say again, sorry.
2021 was when you got out.
That was when I super duper got in.
Oh, okay. And then how long from that until you got out?
2023, January 2023.
Wow. Only 5 years. Would you say Like, do you have any regret for that period of time? Do you think, man, I could have been, I don't know, studying something else? Because I know flat earthers generally spend a lot of time. Like, it sounds like your case is a bit unique because you didn't come through the same routes, but it seems like most flat earthers spend like hours and hours a week watching like Eric Dubin and all kind of flat earth videos that they could have.
Dude, I'm grateful for everyone I met when I was a flat earther. These people were loving. Like not everybody's always going to be nice to you, but
Hmm.
these people really will treat you like they're brothers, and they mean well. And they're nice people, man. Like they don't mean any fucking harm at the end of the day. There's a couple people that I think are, in it for other reasons, but for the most part, like these people don't mean you any harm.
Okay. Let me see what the chat
And
is
like
saying.
everybody's really nice, really gracious. They'll listen to all your crazy thoughts and they'll be your friend throughout. They won't judge you. They're good people.
What about since you got out though? Did they say that, yo, you're a shill, you were never a flat earther and things like that?
Yeah, I got out, but then I started trying to like show them that flat earth is wrong. And that is not why people hang out in flat earth servers. So my presence there, it feels like I'm a troll to them.
Mm,
But to me, I really do think that some things should be obvious. So I try to bring like really, really kindergarten level arguments, like stuff that just should be obvious, and it's almost insulting to have to point something out like that out to you. And that's like my strategy when I try to debate for the globe. Unfortunately, it makes me sound like an idiot and a dickhead. But yeah, these kindergarten level topics is what I like to stick to because it makes people question like fundamental normal geometric things like sunsets and counter rotation in the south.
mm.
Like I don't want to say any names, but someone recently in a debate really affirmed that the stars rotating clockwise in the south is due to their orientation to Polaris. Like they're just like changing their position while looking at Polaris, and
Huh,
that's why the stars end up rotating clockwise in the south. And that's like a really, really like blatant misunderstanding of what's happening in real life
that's right.
because you're not looking at Polaris when you're in the south. So to say that like, oh, I'm changing the direction that the stars are rotating, and I'm still looking at Polaris, no, you're not looking at Polaris. So for the reasons someone could go up there and say that with confidence and not see the flaw, either you're extremely dumb or you're a liar. And I think they're a liar. I don't think they're that dumb.
I got you. Awesome, man. Let's see what the chat is talking about here. Let's see where I left off at. Uh, uh, Catherine. So Lisa says, when Darryl said that in his debate, I didn't know that. Blew my mind considering so much depends on the accuracy of GPS. Yes, they didn't take into account relativity. Look it up. We would all be dry, like that episode of The Office. I don't know if I like The Office where Michael was following his GPS and it made him drive into a lake. That would be all of us driving into the lake if we didn't update the GPS because of relativity. Looks great.
Yeah, that's
Let's see.
fascinating.
Mm-hmm.
Yeah, and you said that there's actually like, you know, you think about instrument error, you think about human error, you think about gravitational anomalies in the atmosphere, like what might be going on to cause these, signals to not reach at the predicted time. And you told me that no, it's all accurate and that you didn't find any anomalies. I'm like, damn, really? You know what I mean? I don't know. It's just like I thought you would say yes. There is corrections made all the time.
Ah, because I mean, other than the correction, because of taking relativity into account, if there was something we didn't know about, but think back to the planet thing. There was something we didn't know about that was causing the orbit of Uranus to not work right. So there was a planet there. So there was something there, I also wouldn't be able to account for it. So by the same token, if there was some unknown variable, your GPS just wouldn't work. Because we'd be like, for some reason we can't get the timing to work. We don't know what it is. And then it just wouldn't work because we wouldn't have figured it out. Just like how if we didn't find the planet, we'd be like, well, I guess gravity must be wrong. I guess I understand it must be wrong because we can't get it, we can't get the timing to work. But there was a planet there once we take that other planet into account, then it works. But in the case with GPS and relativity, it works because our GPS works just fine and we don't have any problems. We just do the calculations. Of course, now we have computers in the thing that do it automatically. We just program the computers. This is what you do, and it just does it, and our GPS works. But if we didn't program it that way to take that into account, then we will all be driving into oceans or lakes. I think it was a lake he drove into. And Lisa says Dr. Steve Hayson has some good books and videos about escaping cults. Getting out by yourself is extremely difficult and quite brave, Kali. I'm very impressed. So some props. Let me read that again. Dr. Stephen
Wait,
Hassan
what
has
happened?
some good books and videos about escaping cults. Getting out by yourself is extremely difficult and quite brave, Kali. I'm very impressed. What do you say to Lisa?
Um, well, thank you. I feel like you are complimenting me, but you know, as somebody that used to be a flat earther, it's really easy for things to sound patronizing and condescending. Like people don't know if you like. I'm gonna tell you something. There's such thing as auto globers. Okay, there's
Okay.
people that never tried to reevaluate. They never washed their slate clean, and they just kept reaffirming things, and they never see through the lens. And some people really don't respect that. Some people don't respect that you can't see through the same lens. People don't think things are happening until it happens to them. You know, you don't ask why people are flat earthers, why people believe in conspiracies. You think everybody's just lying to themselves about their reality. But no, some of these questions are valid. You should not take everything at face value. How do
Awesome.
we get to better understandings of things? By questioning them. If you just automatically believe everything you're told, how are we going to further our understanding of everything? You have to question things even though you think you're right already. That's the
Yeah, I can see
healthiest thing
that.
to do in the pursuit of knowledge, man. You can't just take everything at face value. So these people that are looking at the globe model and they're saying, hey, let's ask certain questions, they're hanging out in their Discord servers. They want to talk to each other about, maybe there's some flaws in the globe. Let's find something funny about it, right? Here comes a glober. Flat Earth is wrong. That's not the point of them being there. These people are really, they're ambitious. Yeah, that's not supposed to be a jab. It's ambitious to believe in these things, but everybody's gonna have their habits that aren't the greatest thing they could be doing at that very moment. Like, why
Hmm.
aren't you doing 100 push-ups right now? So, like, forgive these people for entertaining something that doesn't just go by the globe dogmatic globe stuff. People want to have fun. Let them entertain random stuff. I mean, are they guilty of being stupid because they want to entertain random stuff? I don't think so. Not every time. Some of these dudes are smart as fuck. Some of these dudes, I know these flat earthers are actually fucking smart, man. A lot of these guys aren't just like,
What do you think it is with the smart ones? Like the ones that you know are very intelligent. What is it for them that has them in flat Earth?
same reason I was there. It was fun and the acceptance and the welcoming. It was the warm invite and the topics are interesting and they're willing to listen and they'll be your friend. And that's a cool place to be at first. As long as it stays like that, you're in a good place.
Mhm.
They're not going to judge you for entertaining flat earth. You could entertain anything, man. COVID, all these topics people don't usually like to talk about, things I don't talk about at work, talk about in their server.
Gotcha. Now, I'm sure Lisa didn't mean any offense by the statement, and like even the dynamic that you mentioned just now, because I actually have experience with the Nawabian cult that's defunct now. That caused me to look into cults like Scientology. And that's one of the things that's consistent almost universally across cults is when you get in, you almost get love bombed. Like there's all this acceptance and so on and so forth. But I think I heard you mention earlier yourself that now that you're out of it when you go in, it's almost like you're trolling them. Like they see you as an outsider. Like do you feel like the same love is there? Like when you come in, do they say, "Oh, Kali, yeah, you were a flat earther, but now you're still our brother." Like, do you feel the same love now that you're out?
Certain people, yeah, they're still good friends with me.
As a whole, no.
Not everyone's the same. I got to be completely honest, man. I don't think everybody there is there for the same reasons. I think some people are genuinely interested in the topic and they're curious about the shape of the Earth, and other people are literally just smelling their own farts.
I gotcha. I mean, we can't deny that people will have different motivations, and whether we leave
I
off
mean, I
here
know
last,
about it, dude.
you
I
were
mean,
there.
because I used to be a flat earther, like there was a point where, I would open up a channel in politics and I would call the room flat earth and then people would join. Do you think earth is flat? And like, I used to be a flat earther. I know all the arguments, not all of them at this point, because I haven't been straight up tuned in like I used
That's,
to be.
that's right.
But yeah, I mean, I call these guys auto globers, where they don't know all the flat earth ninja moves, right? Like flat earth does have some arguments that maybe a glober isn't entirely privy to when you first meet them. So it's easy to trip up certain people that just want to reaffirm the globe to a flat earther. Like some of these guys don't realize, like, the level of condescension that comes with you trying to convince a flat earther, like it is going to be hostile no matter what. This person doesn't care to be taught anything. If they're hanging out in a channel, they think they're teaching you.
That's
So
right.
for you to come through and think you're teaching them something about the globe, they think they know more about the globe than you. And that's the reason they're a flat earther, because they already debunked the globe and you're
That's
an
right.
auto glober and you didn't think about it yet. You didn't study the cosmic microwave background. You didn't look at the flaws in relativity. You didn't look at the dark matter, God placeholder, like all these things that reaffirms flat earth to them that I tried to lay out today. Yeah, they hold all that stuff like a sword in their debates. And
Hmm.
they're ready to like swing it at some unknowing glober that doesn't know that all these arguments exist. And they take pride in those arguments. A lot of fucking egos grow because they win those arguments. Not everybody's ready to talk about dark matter like
That's
you
right.
were today. Yeah, it's really easy to trip up somebody that doesn't know these topics.
Hmm.
And flat earthers, they take pride in like looking into these topics, like having citations, talking about the electric universe, talking about misunderstandings of gravity, like equivalence principles and all this thing.
Have
You
you
know,
ever seen
that's
somebody come
where,
in
yeah,
that knew the topic, that joined the conversation, and saw how they responded to that?
yes. And those are my favorite debaters.
So what
Those are the people that I love listening to them debate, man. It's fucking great content.
But I mean, like when you were still a flat earther, when you were still in there, like how would that go? Like somebody comes in, they answer all the questions, they leave. What happens after that? Because one thing, reason why I bring it up is I think you bring up something very interesting. Because I remember one time I joined this flat earth Discord, and nobody knew who I was, and I let them know that I was like researching flat earth and I'm writing a book on it, on the topic, and they said, oh, but they still was trying to convince me to be a flat earther. And one of them had brought up the what is it? Or the black swan they call it. You familiar? They don't talk about it as much anymore, but at this time it was like a big deal, like the black swan, black swan. But I had already seen the bunk and understanding of it. Of course, now there's a whole lot of pictures out with the on a regular day where you can see it cut off. But at the time, I asked them, I said, "Look, I said, where is this at? So I can go see it myself. Where is it?" And I was serious. Where is it? I'll go check it out. And the guy who I was talking to said, "Oh, well, you can't. It doesn't happen all the time." But the thing is, when they first introduced it to me, it was like, man, this disproves a flat earth. This is the way it is. Like the way they first introduced it, it was like, man, this is this, you could see too far here, and this is this proof. But when I actually brought up going there, then it was like, well, actually, hold up, it's not all the time. Well, if it's not all the time, you could only see it in a different certain point. Why did you even bring it up like that? Didn't want to talk about something else. So it seems to me that when they get somebody who understands it to some extent to not fall for the regular argument, they just change to something else. But the other point is when I came back another day, they would still talk the same point. So did you find that when somebody came in that had the answers, they still went with the same arguments as if it was never explained to them?
Oh gosh, that you are highlighting such a sensitive issue with I
Okay.
don't want to make anybody feel like I'm talking about them. But yeah, there's certain people where like, they'll act like it goes in one ear and out the other. And it
Yeah.
makes me think that they're dishonest.
Mm. I really believe, like the person I was talking to, I do not believe he was trying to trick me or lie to me. I really believe within the extent he was capable within the thought system, he thought he was helping me. And it seemed like there was some blockage in his thinking that just would not allow him to sit with the fact that it doesn't happen all the time. But then he just went back to it when the next person came in who didn't know. How many people did you see get convinced like that? Like somebody who came in, they didn't know the arguments, and the person brought up, dark matter and CMB, axis of evil, and so on and so forth, and they were converted. How many people did you see get converted?
How many people did I see get converted? Zero. I mean,
Really?
I'm never truly present. No, I can't say that I've seen somebody literally start questioning the globe in front of my eyes.
Yeah, and when I say see, I mean I don't literally mean right in front of you, but I mean, somebody came and there was a glober and however long they were flat earthers. Like, did you see anybody convert, or did everybody that you know of as being a flat earther came in as a flat earther?
Oh, like other people that are now Globers, you mean?
No, 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 no. Like somebody that came in that was a glober, and they heard the arguments and you know of them converting. You know,
Oh, like so. I don't. Nope. No idea.
interesting. Let's see what last questions we have here, and then we'll see what things you may want to wrap up with. Uh, Lisa says this is a follow up to the previous comment. She says, luckily, science is all about questioning everything because someone could have a better explanation for something that was taken for granted. For more than 1,000 years, they believed Earth was center of the universe. What do you say?
Uh, yeah, yeah. You have to keep questioning no matter what.
Yeah, but I mean, your point is valid for a lot of people though. Like, when I first heard about flat Earth, I can say I guess I could be what you consider to be I think you call it an auto glober, because I mean,
Not
I look
every Glober is not a Glober.
definitely, but I mean,
You,
I could say I was one.
I wouldn't say you're an auto Glober, honestly,
Well, I'm
because
not
you
now, but I'm just
are
saying back
going
then.
to
Now, of course, what I'm just saying, the first moment I heard about flat Earth, I think that was a fair assessment of me because I can't say I looked through telescopes, or I can't really say I did my own experimentation. I just, we were taught the Earth was a globe, and that's one of the things I realized. I was like, okay, well, I guess they're right. I didn't really look into it myself, but of course now, I mean, I don't know how many times I've taken my telescope out, and I've taken my day telescope out. Of course, I went back to college. Now I've tested gravity. Ironically, if you talk to any physicist, none of them are an auto global because you can't get a physics degree unless you thoroughly test all this stuff. I know that from experience. Like you can't get a physics degree unless you have almost every physics class has a lab, and in that lab you have to do experiments and tests and recreating things, and you get out like I got out knowing gravity is real. I got out knowing that the waves is real. I got out knowing quantum is really a thing and electrons exist. All of these things I had to do experiments. This summer,
Let me tell you something. I want to tell you a story.
okay, go ahead.
In what year was that? 2017, 2016. I was in a completely unrelated type of server. It was actually for music.
Okay,
And there's a guy in the server in a voice chat with like 30 people. And he's like, yo, I don't think Earth is a globe. And there's like all these dudes are attacking this guy. Like, dude,
okay.
we have satellites, like the moon, like look at all these. And I'm sitting there, I'm listening, and I'm just thinking, like, dude, I want to jump in and I want to tell this guy that we went to the moon. I was just gonna be like, yeah, dude, we went to the moon. In my mind, when I think about that day that I was listening to that guy, I was an auto.
All right, I got you. I understand. I
Yeah.
think that's a fair assessment of most globers. Because again, because most people are not scientists. Most people just, they do whatever they do, but it has nothing to do with science. They're smart people, intelligent people, but they don't look through telescopes or measure things falling and calculate Newton's equations and all of this stuff. Um, so it's fair to say for most people, I think.
That's right. That's exactly it.
And Derek says they finally backing off the Horizon rises to eye level dumbness after 10 years, some of them. I do remember that. Horizon rising to eye level was pretty big. Matter of fact, you mentioned Bob the Science Guy. He's a pilot. He did, if I remember right, I'm pretty sure he did one of the HUD, you can see the level of things and we see the horizon drops. If I remember right, MC Toon did one of them on an airplane where yeah, he did. And you can see the moon lower than the horizon. So what's your take on the Horizon rises to eye level thing?
Yeah, clear misconception of what happens in reality. All
Mm,
these people picture like this time that they climbed a mountain, turned around, looked at the horizon, and it appeared to be at eye level, and they imagine that that is the case. But you can just go ahead and fucking measure the difference between the horizon line and a level,
that's right.
and it's going to show a difference. You can measure the angular difference, and that'll give you a dip angle.
That's right.
And then, yeah,
Even
then
on the
keep
top of
moving
a
forward
mountain.
with that. You go ahead, yeah, take elevation angles, doing all that kind of stuff. But there's something I really wanted to talk about.
Go.
So when I asked you before about anything appearing anomalous in astronomy, like I really don't get the opportunity to like really ask some hard questions, right? So I'm gonna
Okay.
try to ask you a hard question,
Okay. Let's go.
if you don't mind.
Oh, yeah.
So, like, I talk to people about God a lot, and I think that people that think that matter can exist because of itself, or that there is no cause to matter, that it just is because it is. Like, what is your true perception of like what causes energy? What causes what we observe? Like, do you think that there has to be a cause effect relationship to what we observe in matter? Like the existence of matter. Why? Is it because of itself, or is there something outside of matter that causes it?
Well, the scientific answer is simply that we don't know. The only way we can know is if we were able to look beyond the Big Bang, which we can't do. So the scientific understanding is, to my understanding, is it just we don't know. I don't think scientifically we could ever know. Yeah, so I think that's simply outside of our ability to know or understand. I think just science would point out that our lack of knowing that does not mean we can uh, uh, you know de facto insert God or anything else. It's simply that we don't know. I guess it reminds me of something I saw Neil deGrasse Tyson mention, how somebody asked him about UFOs and are they really aliens or do you think they're aliens? And he was like, well, the fact that we call them UFO, unidentified flying object, means we don't know what they are, so we can't just assume they're aliens because we don't know what they are. So I think, from my understanding of science, when we have his take on that, I think the take will be the same thing with what was the ultimate cause of matter. Well, we don't know. We can't see past the Big Bang. We could see that there was a Big Bang. We could see the CMB, the result of it. So but we don't know.
Yeah, I really respect your answer.
Thanks.
Um, well, I wanted. Do you like talking about that kind of stuff? Because I could go on and on about that.
Sure.
The
Yeah, what's
truth is
another one?
that I like, what really makes me interested in all this stuff, for me personally, just like I'll let people take digs at me. I don't care what people think of how I perceive what's going on. I'll just be flat out honest. We observe pi and phi. Like you look at life, we observe what we think is going on a molecular level. We think that we can represent reality as like these spheres.
Okay.
Would you agree?
Do
All
you mean
right, so
like
we got
planets?
pi on a
Oh, you
I'm
mean like
talking
literally
about
pi,
molecules.
pi,
Right now, I'm talking about
3.14. I
molecules.
got you. Yeah, yeah, yeah.
I'm talking about quantum. On a quantum level, we think we're observing spheres. Is that a yes or like? I want to know if you
No,
think that spheres are existing in nature on a quantum level.
no. I'm not aware of us observing spheres on a quantum level.
All right. Well, then there goes me even trying to talk about that.
And I want to be clear, I'm understanding your question. Like specifically, like name one of these spheres. Like specifically, what are you talking about?
Like, what is the description of an electron? Like, do we say that electrons are these tiny little balls that are, orbiting the nucleus?
No. Okay. So let's go through this. We had to actually. I'm about to take quantum for the second time because I didn't do as well the first time. I could have just passed with a C, but I'm not gonna do better. That was just a hard class, but I did go through the class. So the way they broke it down is this, the progression. So as a rough history of how we get to our understanding of electrons and quantum. So the original model of an atom was that they were solid objects in themselves. Just an atom was a solid thing. Then we had an understanding that they were sort of like a pudding. They called it the pudding model, where we thought that atoms
What
were.
year was that?
I don't
Sorry to
remember the
interrupt.
years, but if you look it up, it's like if you look in any like physics book that talks about the little history of a physics, but I don't remember the year. If I was to guess, it had to have been like the early 1900s. But they thought that an atom was like a pudding, where you have like a pudding with raisins in it, and it was like, well, the whole mass is an atom, and there's these little parts. But what they did, I think they did something like they shot things at an atom, like they shot small particles at an atom and realized that either they would just miss or they would bounce off like they hit something really hard. And they did this enough to where they realized, oh, there must be some kind of solid thing there. And eventually we got the model of a nucleus and an atom. This is probably a very rough history, but you can look it up. So now we
That's really
have
interesting.
the history of a nucleus and something going around it. And we thought it was like a solar system, like the nucleus is a planet and the outside is the electron. And we wasn't really sure about the charges. I can't remember the exact experiment they did to determine the charges of things, but my professor went through the whole thing. It was pretty interesting. But maybe I'll look it up and make a video on that or something. Maybe I could even have you on when I do it. But suffice it to say, eventually we started to realize that electrons don't behave exactly like particles. And one of the experiments that came to that realization was something called the double slit experiment. So we know that if we take, let's say, water, right, just water, and we drop a rock in that water, it makes a bunch of waves that radiates outward. Well, if you put these two slits, if you like put a wall in the water and make these two slits and drop that same rock, so now you have one wave that's radiating, but when it hits the wall, there's these two slits. One part of it goes through one slit, and one part of it goes. Matter of fact, let me draw this on a whiteboard. I forgot we have a whiteboard here. This will make this clearer. So, whiteboard, screens. Maybe we don't
I
have a
appreciate
whiteboard.
that.
Welcome. Okay, I'm just gonna have to share my paint. Let me open up a paint. Swear there was a whiteboard on this thing. What happened to the whiteboard?
I got some funny Microsoft Paint stuff. I really do.
So let me know when you can see this paint thing here.
Yeah.
Awesome. And well, I guess the people at home can't see it at the same time, but I'll click it again so they can see it momentarily. Okay. So we have the puddle. I dropped a rock in the water. So the waves are radiating from the rock, right? So that's the rock at the bottom, the waves coming. I have a wall here, but you see there's a break here. So that's like a wall in the water, but those are the two openings. So there's an opening here and an opening there. So that's an opening in the wall. Okay. So when a wave goes here, a little part of the wave goes out, a little part of the wave goes out, and then they start to interfere. And where they interfere constructively, they add to each other. and where they interfere destructively, they cancel each other out. So if you look, let's say uh, here, the two waves are like they're pushing up with each other. So that's their bright spot right there. And then this part here where there's an X, they interfere and they cancel each other out. So if, let's say, you had colored water and you're able to make colors on the wall, you'll see a fringe pattern where there's a light, dark, light, dark, light, dark. But what happened is this guy did this with electrons. He sent electrons at two slits, and we got an interference pattern with electrons. Another thing he did that I found out in this quantum class, and I read the paper on it actually because the professor listed the paper. Um, Crystals have these very uh, uh, because they're crystal, that's why they're crystal, because they have these very distinct lattice structures. And the distance between the different atoms or molecules of the crystal are very fixed. You can take an electron and fire it at a certain angle at crystals, and it will also give a diffraction pattern. So many different experiments show that electrons behave like waves, right? At the same time, if you shoot an electron through a double slit one at a time, even though you're shooting one at a time, it'll still interfere with itself. So suffice it to say, we know that electrons are not these strict balls. At the same time, they are not just waves because again, they can behave like balls as well. Like for instance, in my EM class, which I help in,
Or like particles,
particles. I
rather.
meant to say yes, like
Yeah.
particles. So for instance, if you take a stream of electrons, right, and you shoot a stream of electrons, and you and put a magnet to it, the beam will bend according to EM laws that we know. So, in one hand, they behave like a particle, and in one hand, they behave like a wave. But the fact is, we don't know exactly what electrons are. We just know that sometimes they behave like a particle, sometimes they behave like a wave. And I guess the most advanced model of an atom that I know of is that the electron is more like a field that surrounds the electron. I mean, the atom. And in my survey class, where a third of it was quantum, a third of it was relativity, and a third of it was thermodynamics, even though sometimes I think it's statistical dynamics because there's so much statistics in thermodynamics, but it's thermodynamics. In the quantum aspect of that class, that professor, this is the professor I was telling you, he does experimental research at CERN. But I mean, this is what he does. He actually put a model of the atom on the board, and I mean, it's just complicated. The dude, I mean, he's deep. And
That's interesting.
I try to draw it for you what it looks like. One moment here.
Yeah, that I'm interested in that.
Yeah, yeah.
Can I say something to all
Go
that?
ahead. Go
Yeah.
ahead.
So, everybody's gonna remember, you know, chemistry in high school or in college, in the textbook, the image of the circle and the sticks.
Hmm.
Those are like molecular bonds, right? So when you
Yeah,
tell
yeah.
somebody like, "Hey, I got my electron microscope and I'm lensing something times 1,000 times 1,000 times 1,000," and it's not the little circles and sticks, right? That's what you're saying, right?
No, no, because we have to actually calculate this for my well, I guess we didn't so much calculate it for my chemistry class, but we had to learn about it and actually see how the levels work. But in quantum, we describe it in a sense that these are probabilities. Like when you do quantum mechanics, you can't precisely calculate the location of a electron. Is a probability distribution. And there's a probability of an electron being here versus there, and you get a probability curve, and that's how we determine where the electron most likely is. And it starts to get pretty complicated. We only focus on the hydrogen atom. Beyond that, it gets very complicated. But no, our understanding of electrons and atoms now is that it's not this little sphere. It's a there's a proton and an electron surrounded by a probability distribution, and we can find some probability of where the electron is. And then when you when you combine molecules, we might still sort of model it with these sticks and balls. They still did it in my chemistry class. But even in that class, they still mention the fact that this is just an approximation and to talk about the quantum nature of it, and it's not really what it is. So similar to, I'm sure you heard the argument how when they point to a flight manual and it talks about, we model the Earth is flat and the plane is rigid. That's what the stick thing is. There's a stick and there's a ball, and the ball is it's just a simplification because the reality is so much more complicated. And that's why in the
So
quantum class we just stick with the hydrogen atom because it's simpler. Go ahead.
I'm really grateful for you breaking that down. That was actually really great,
You're
and
welcome.
I think really necessary for the conversation.
Awesome,
And
man.
now I must say, um, what's it called? So what I was getting into before about, pi and phi in nature, I wanted to use things on the quantum scale as another example of observing pi in nature, but I guess you don't agree, which is fine because I agree with what you said. But we still observe the moon, we still observe the sun, we still observe you know, Fibonacci like in seashells and
But I mean, do
spiral
you know
arm
what pi
galaxy.
is though? Like, do you know what pi is?
Do I know what pi is? I mean, you want to hear me just fumble and stumble, or you want me to Google it?
I mean, from your perspective, I'm saying from your perspective, where you think it's so important at this level, what is your understanding of what pi is, where it seems important enough to try to model it on these spheres?
Yeah. Well, it's just it's an irrational number in math,
Okay.
and I think that in a sense we observe it in nature.
Hmm. Okay, let me show you what pi is. And I know people at home, you won't be able to see this right away, but I'm gonna get this worked out. This is my first time doing a sort of one like this, but just give me a moment and y'all be able to see it. But you'll be able to see it right away, Kali. So if you have a circle, let me draw a circle here. All right, so that's our circle. I know it's not perfect, but imagine it's a perfect circle. The circumference of the circle, so we have the radius of the circle here. That's our R. Oh, I forgot, I still have it set on circles. So that's the radius R, right? And if we want to know the circumference of the circle, it's going to be the radius, and then you have to go all the way around, like the length of the distance all the way around that thing. We have to go that far from the center and walk around in a circle. So this distance here is the circumference, and we're going to have I'm reversing. I keep wanting to go back to the reversal. Well, let me just write it. That's the circumference. You go out the radius and you go around twice. Now, a radius is half the width of a circle, so the full thing is the diameter, right? We agree with that, right?
I
So
want you
this
to
is
stop.
okay.
No,
Okay, let me back up. Let me back up.
no,
So,
just understand this. Understand this, dude. I
okay,
understand geometry. Okay, I'm not that far behind when it comes to
okay.
what pi is. Okay.
So you
What I was
understand?
saying was, what I was saying was, if we do observe these spherical, we have oblate spheroids in nature, right? You think that Earth is a sphere? So somewhat in a way, that curve, the rate of the curvature is represented as an irrational number sequence. So pi in nature. What I was trying to say was, it appears that where there is nothing, that there is pi and phi. You have to really take this funny little walk with me. If you want to have this conversation or not, I don't know. If you're so rigid in this other stuff. Or
I guess just from my perspective, like it doesn't seem like I guess the perspective of pi in nature, how you're wording it or how you're describing it, it makes it seem very sort of mystical or spiritual in a sense. Um, but from my perspective, pi is just uh, the circumference divided by the diameter. You know, if you take any circle and you divide the circumference by the diameter of the circle, you get pi. That's just all pi is.
yeah,
And,
we observe that in nature.
well, I mean, like the spheres that we see in nature, that's just gravity. You know, if you take anything big enough, if you take any large enough clump of mass, it'll contract the point itself because of gravity. And gravity works in all directions. So you have all directions pulling in on itself, and that just forms a sphere. That's just, if you have something collapsing on itself in all directions, that's just the shape that it makes. So I guess like from the raw sci-
Exactly. Yeah,
scientific perspective, yeah, I guess uh,
that's exactly what I'm talking about.
yeah,
Yeah, we observe surface tension. We see things that form a curve. So we see curves forming in nature. So if you ask me, it appears that like all matter kind of is just under some kind of influence of these laws of
yes,
geometry. Yeah,
underneath the
right.
well,
So it's like this funny thing going on, right? Like what's really going on there?
I guess I still don't think it seems funny. I mean, like if you know, if you say the law of geometry means that a sphere happens to be a shape where uh what's the exact word? Um the everything reaches the lowest potential energy in a three-dimensional direction. I mean, that's just I guess you could say it's a law of geometry, a law of nature, but it doesn't seem mystical. You know, any more than you know, you put your hand next to a bright light, it feels warm. That's just the nature of the way light bulbs work because it's heating up the filament. That's just the way it works. You know, you get a whole bunch of mass, it contracts until everything is at its least potential energy, and in a three-dimensional direction, that's a sphere. Just like how if you drop water on a flat surface, it flattens out. You know, so I guess I don't know. I guess maybe I lost some of the wonder that comes from looking at it from a certain perspective, but I don't know. I guess it doesn't seem like a big deal to me. What do y'all say in the
Actually,
chat?
this has nothing to do with the flat Earth at all. I'm talking about spiral galaxies. I'm talking
Spiral
about
galaxies?
literally observing Fibonacci. Matter takes the shape of the Fibonacci.
Okay.
Yeah, like what's the real cause of that? Like we think that our understanding of matter and energy is going to tell us why things take the shape of Fibonacci, or is that just something that we just plug in? I don't know. If you don't see where I'm trying to go with this, it's okay.
I guess like how did you determine that it takes the shape of the Fibonacci? Like
Well, yeah, that's what we observe. We observe the life grows in these spiral patterns.
like I vaguely remember Fibonacci where it's uh like a pattern that goes around like you have a short line, then it curves to the right and it's a longer line and it goes to the and there's a longer line and a longer line. In that class I was telling you about where we studied the galaxies in the cosmos, we looked at many different types of galaxies and I think the idea you have of a galaxy is like you may be thinking about how the Milky Way galaxy looks, but that's not the way
Yeah,
most galaxies
spiral
look.
arm galaxies. Yeah,
But that's not the way most
spiral arm.
galaxies look. Um, you know, there's some galaxies that are they call them bar galaxies where the center is a bar, and many galaxies are like that, where the center is bar, and some of them only have two arms. There's elliptical galaxies, which is a large swath of galaxies where I guess it takes a more gaseous shape like a cloud, and all the different stars are moving in different directions. They call it elliptical. And there's so many different types of formations that I believe it was Hubble. I can't remember who was it, but they formed it into sort of a, they called it, I believe, the key format of galaxies, where there's many different types of galaxies. So I guess I just say that from my understanding of studying galaxies, all galaxies don't fit that shape and pattern. Matter of fact, most galaxies don't. So I would suggest to you that that characterization is based upon a very, very small pool of all the different shapes that galaxies take. So, I would suggest getting an astronomy book on galaxies and study galaxies and then see. I mean, maybe if you look at it in more depth, maybe you might be able to find something that fits. But just off the top of my head, from what I know of galaxies, there's such a wide array of how galaxies look. um, that
I'm talking about the
I don't.
spiral arm ones.
Okay, well, I guess if you
Hey,
fit with just
there's
the
plenty of examples of spirals in nature. You could address that,
true, there are many
or
examples of
you could
spirals in
keep
nature.
being disinterested. It's all good. Yeah, it's not for everybody.
Hmm, let's see that. Let's see what hold up. Real Cognitive says pi is a mathematical constant that appears in many places that don't seem to have anything to do with circles, including in quantum mechanics, physics, and nature. Well, pi definitely has directly to do with circles because pi is just the circumference of the circle divided by the diameter. I believe that's where we originally got pi from. Um, but awesome. And Real Cognitive says math, mind, nature all have something in common anyway. It could be a phenomenon we might understand better in the future, Lisa says. Awesome. Before you wrap up, what's any closing things you'd like to say, or anything like that, or any closing questions and comments, or any closing things to any of the people who in the chat who I mentioned their questions and comments to you? You have anything to say to them or anything at all?
Yeah, I do. Instead of trying to hyper analyze what's wrong with flat earthers, you should hyper analyze why you care to get to know flat earthers so much.
Why we care to get to know them so much? What do you mean?
Well, how involved are you in the flat earth? Like, technically, your involvement in the community makes you a flat earther. It doesn't matter if you think flat earth is real or not. So, all this time you spend, you want to condescend towards other people and act like you're smarter than them. Like, ask yourself, why do you spend so much time trying to condescend to flat earthers? Is it because you're trying to validate your intellect because you don't feel like you can in real life? And then the only space you can do it is in a Discord server where you're talking to people that you think are much less smart than you? Is that the only time you feel like you're actually smart? You have to ask
I could
yourself
answer
these
that
honest
for you.
questions. How you spend your time talking to flat earthers and how you treat people in life. If you don't believe in God and you think it's cool that you just go and condescend and tell people they're dumb all day and you think that's normal behavior, those people are looking at you like you're fucking vaccinated. You think men can be women and you hate God and you have no reason to be invading on these people's spaces where they should be allowed to demonstrate their free speech and entertain subjects without you bombarding and trying to demean and condescend.
Well,
That's
I
all.
could answer that. I think the first thing that got me interested in flat Earth was I didn't believe people really believed it. I had mentioned briefly how I knew somebody personally. A good friend of mine had got into flat Earth. Matter of fact, he's still in it now. And before him, I thought it was just some kind of satire. I had mentioned as well how before I knew about it, I could be considered sort of an auto glober. I didn't really do my own research. Like talking about this before I went back to school for science and physics. So it motivated me to start looking into it directly because, like I said, well, I guess I can't really say I know from my own experience or whatever. So I got like a telescope. Like I say, the reason why I debate now and get in and involve myself now, uh, well, generally I find it fun. And also it goes back to what I said at the end of my debate. And maybe I'll play it momentarily so you can hear what I said. And it speaks directly to what you're saying now. So give me a moment. I'll share this on my screen, and I think the people at home might be able to hear it. I'm not sure. But it's at the end of the debate with Witsit where I pretty much uh, address this. One moment.
The misspelling.
Certainly.
It's so
One,
hilarious.
1 minute, you say?
Go ahead there. 1 minute closing.
All right.
Darryl.
All right. So this is my 1 minute closing. I'll share my screen with you. Let me know if you can actually hear it. I don't even know if I can. I believe it'll let me share sound to this thing. Let's capture application. So this is at the end of my debate. Is at 3 hours and 8 minutes. Let me know if you can hear it, by the way.
What do you think
debate
of our
is this?
discussion tonight?
My debate with Witsit that was on this Sunday.
Yeah, I didn't get to watch this yet.
No problem.
My bad.
That's okay. Let me know if you can hear this right here.
Maybe something else you might want to debate in the future that we haven't touched on tonight, and where everybody can find you.
Were you able to hear it? Were you able to hear anything?
It came through for a second and it stopped.
So you did
press
hear
pause?
Ryan talking?
Yeah.
Good.
Yeah, I can hear.
Okay, so I'll go ahead and back and play it. All right. So thank you for having me, Ryan, and James, wherever you are. I know he's busy. I guess I want to close with a note of gratitude. So for the little amount of time that flat Earth and geocentrism has risen again in the human society in this very small amount, and for the short amount of time it'll still be here before our technology so outstrips it that it'll be so horrible for people to believe it. Thank you, because you've motivated me to study a little bit harder and do a little bit more empirical firsthand investigation and learning. And I appreciate that. It was fun being here. It was enjoyable. Hopefully, you all learned something. It was fun to be able to share some of my research that I'm working on. It's still in the initial phases, but you'll see me again. Maybe I'll make a full presentation on just the sun rotation. And if you're interested in some tutoring on math, physics, hit me up. And I'll see y'all next time. So I had mentioned how that's one of the things that really motivated me was I saw the errors in thinking and in evidence, and I thought I want to not be like that. So often when I'm studying, I'll think, wow, uh, somebody believes this about this, or something like that. So it's really a motivation to me. So yeah, I think that's my thing. It's
Yeah,
enjoyable.
I think you are a blessing to the community, man. And I'm grateful to have talked to you today.
Awesome.
And there's so many good things that can come from just like, you know, having good interactions with each other and not making it all weird.
Sounds good, man. Thank you for being here, Callie. I appreciate you. Thanking everybody for showing up and putting some dropping some lines in the chat. And I'll go ahead and drop the stream, and I'll see y'all next week.
All right.